Good morning, everyone. It's a great pleasure to be presenting here at Bristol Tech Fest. I was lucky enough to make it to the opening evening where Dave Tansley, one of the vice chairs of Deloitte, talked about ridiculous optimism. It is also a Kermit the Frog quote, I should hasten to add. But I share that optimism, particularly around space drones and geospatial data and how that can have an impact on the welfare of people, the climate, but in factors of life and how we do things that haven't really been explored before. And so I think the optimism is that we are coming together at a very unique time, which will allow the data to be able to be driven from this to make a real change going forwards. Now, it is also, we're at Bristol Tech Fest. Whilst I don't live in Bristol, I'm afraid I'm based down in Exmoor. The excitement around this space drones and geospatial data in the southwest, I think, is incredibly exciting one, from the spaceports in Cornwall to the vertical aerospace being an eVTOL organisation based in Bristol, and the vast heritage Bristol has in the aviation sector, to the geospatial market and the incredible universities. Sarah Kruger, who was going to be presenting this with me, is an alumni of Bristol and in computer vision, did her PhD in computer vision, and there is great talent and startups that are doing amazing things within the geospatial market. And one of the things we're going to talk about today is sort of why do we form SDG, space drones and geospatial, and then lead on to the impact that a digital twin can have on the workplace. But I just wanted to set the scene. I lead space drones and geospatial for Deloitte, and throughout the course of the Tech Fest week, you'll hear some of the team talk about differing topics in that. And I'm lucky enough to be able to talk about why do we bring space SDG together, and what does it mean? And hopefully there's some alignment for others in the audience around what it can mean for their business. So the space, the National Space Strategy was delivered, I think, the 27th of September, and the government see it as a huge growth area. 6 billion over the next 10 years will be invested into the space sector. And by understanding the capabilities, having more microsatellites launched, what the next constellation plans are, what the future of those are, allows us to understand the impact that it has for our businesses going forwards, be it position, navigation and timing for monitoring and allowing drones to be able to fly beyond visual line of sight, or and that's then increasing the capability of the Earth observation requirements from satellites blended with unmanned aviation to be able to create a more impactful business solution. The second is that we see a rapidly growing unmanned sector. It is led to believe that it will be 48 billion to the UK economy by 2030, which is incredibly exciting. There are some challenges ahead, and there are some things that to enable it to be scalable. But again, it is another tool that will enable businesses to get a view from above, be able to create digital twins at a different cost price point, and hopefully unlock some of the business value going forwards. And lastly, the geospatial market, with the advent of cloud computing, much larger storage capabilities, lower cost satellites, higher frequency of passover rate, huge analytical output that's been driven from spatial data, be it Sentinel or one of the other satellite systems. And then the last reason we came together around SDG was, and this is a plug for a government tender that is out at the moment, or a framework that is out at the moment. It's actually a DPS. It is in that they are looking at aligning around the same categories. So the DPS is a way for government organisations to be able to buy space, unmanned, remote sensing, geospatial capabilities for government departments going forwards. If you would like any more information of that, please drop me a line at the end. I would just hasten to add that unfortunately I am on a single screen in an office, so there are two things I can't see. One is my notes, which were a part of the PowerPoint, and secondly is any questions. So once I finished presenting for about the next 20 minutes, I will we'll go to the questions. So if they are, please put them in the chat window and we'll pick them up at the end. So you're probably thinking, why is he talking about SDG when the topic of conversation was a digital twin? So what we're looking at is how do we harness the powers of a digital twin? I just wanted to set a benchmark. I think digital twin is a little bit one of those terms like AI, where it can mean different things to different people. So this isn't necessarily right. This is what it means to us and how we go about defining it. The digital twin we break into two areas: the physical element and the digital. We have done a lot of work around assets, copying processes or systems, being able to then simulate and optimize on top of that process to generate value, simulating effects before they would otherwise happen and understanding what those are, and therefore being able to maximize a workflow, whatever it is. What we have looked at here is by integrating a physical twin, what that means to be able to increase the capability of that workflow. There are in itself some benefits of physical twins that we will touch on in terms of things like safety, remote working, understanding those elements, change detection, codifying and automation. But really what we look at and how we define where we go with a physical twin is around how it can integrate into someone's business to answer a business solution. What we have created going forwards is a program called AssetMesh, which I'll come on to in a second. But as part of that physical twin, what it doesn't necessarily mean is that you have to visualize it. It's not something that you have to, by creating a visual representation, that is in its essence a physical twin, because you could have a physical twin which is a photo or a dumb 3D model. What we actually want to try and strive for around a physical twin is to be able to codify the reason of why it is there and what someone is looking at or what the business is trying to understand with that, and then be able to deliver the business upscale through data or simulation and optimization. So it makes the decision-making process between the physical and the digital seamless. As I say, it is more than, and in a lot of situations, the visual isn't required. The problem we have is that when you talk about visual twin, and I include myself in this, we are not ready to accept that we're not ready to not touch and feel it with our own eyes. That's why the immersive experience of augmented reality over seeing it on an image that you click around is completely different. But actually, the business output is that, what is it that you're looking for? Are you looking for, has that crack increased? Has this? How do I best move these objects around to optimize it? If we can codify that, we can then drive even greater value from these going forward. So that's just a quick baseline of what we define and determine as a digital twin. It is both the physical and the digital, and it is a representation of the 3D world, not necessarily a visual one. So as I said, we're in partnership with Google. Deloitte looked at building out a digital twin platform that would enable us to drive geospatial insights. AssetMesh is combining accurate, intelligent models with wider location data. There are lots of location-based modeling tools out there that look at that model in isolation, and what we wanted to be able to do was combine that with standard geospatial toolings and be able to give not just the intricate picture of the object or the asset that requires that deep level understanding, from, as I say, millimeter crack detection through to antenna recognition, whatever it is, but actually how does that then scale up and impact in the environment. So if you're looking at a site survey, an engineer might say, well, I can do that remotely, or I can do this, but actually the road is closed, or the site is overgrown, access is hard, all of those things that create the fuller picture of where the digital model sits within its environment. The second piece is around the creation of a true intelligent 3D model. I am not going to profess to have coded or written any of this, but what we wanted, and the challenge was around how we normally when you do computer vision, and I'll come on to computer vision a bit later, it's normally done on a 2D flat photo, and then you stick those things together. By codifying a 3D object to try and achieve scan to BIM, which was one of the challenges the client gave us, we had to come up with a way of creating usable mesh models, and we worked with one of our partners, Point Views, around helping us take the objects, tagging them in a 3D environment, creating an intelligent mesh, and then overlaying the photogrammetry on top of that, so that we can pick up objects within the environment, move them around. We understand the metrics that are attached to that object, and then being able to see what that means in the wider environment. As I say, through this presentation, I will talk about AssetMesh, but hopefully in a way that talks about the concepts rather than hopefully coming across as too much of a AssetMesh sales pitch, which then will drive, which hopefully by understanding the thinking of why we created it and what it does, will hopefully be of excitement to SMEs and other organizations going forwards. So when we create a physical or digital twin, we look at the business problem. We look at what is it that you're trying to achieve with it? Where is it in the life cycle of the program that you're doing it? Is it a post environment? Do you want to do real-time monitoring? Is it a is it pre-environment, real-time monitoring, or a post analysis type work? Is it that you're in the design phase, or say if we take construction, are you in the design phase of construction build? Are you in the real-time monitoring of that construction site? Are you in a ongoing state? And depending on which element of that it is and what the initial business case is, will determine what level of data. As most people will know, the collection of data is incredibly expensive, or can be, depending on what the business solution you're trying to answer is, and how you then, once you understand that business problem, you can look at the collection cost base, the flow rate to be able to get it to and integrate it into the right people, and I'll come on to integration in a minute, which would then mean that it either makes sense or it doesn't make sense. There are some elements to that where by having a high fidelity base model will then allow you to create and quickly scale to business solutions going forwards. But again, I'll touch on that in the last slide. So collecting the right data at the right time. There are many sources, and we are incredibly data rich, particularly in the visual and RF space. Satellite imagery, drones, IoT devices, sensors, but also free source. Like, we created a solution for the insurance industry where they could quickly evaluate a building's state at a current point in time based on analyzing Google Street View. And we did something similar with laying 5G cable and doing pavement assessments. The cost of digging up a bit of tarmac compared to a cobbled street is very different. So it allowed very accurate understanding of estimation of pricing, including optimization of routing, which then linked with how do you work out which is the best building to lay your fiber to in which order, depending on your asset return, your financial return. We then look at how do we fuse that data together. Now, that fusion is normally very complicated and very manual, and we are on the start of that journey going forwards. We then, as I've discussed, look at what is it where we can use machine learning, particularly, and computer vision to add value to the asset as it sits. And then finally, from a Deloitte perspective, is that some elements will want to be able to visualize it, have KPIs that sit in that own environment. But really where we look at the value being scalable is how do you integrate it into an organization's asset workflow? How do you work with the large organizations around the world that will have a very large SAP asset register? How do you create one single point of the truth in a data environment that will allow the work of the digital twin to be able to not seen as a hindrance, but a seamless part of their business workflow going forwards. People don't want more systems with more logins. It has to be surfaced in a way that is unintrusive. So we looked at some principles around that. Obviously, it was cloud-based, but also, whilst I said we delivered in partnership with Google, actually it is cloud agnostic. You are not going to, or it's very difficult to move a whole organization away from their cloud strategy based on your digital twin strategy. And so therefore, it was very important that it was cloud agnostic. And I'll come on to all of these feed into the key assumption going forwards. The other is that the client needed and wanted control of their data. We saw in the marketplace a lot of fatigue around that. You would pay for a service, it would go off, even through an API, which is not the answer to everything. I mean, it does create a great amount of wealth for us in terms of what it allows things to do. But they felt that it was this black box scenario where they came back and they had a model, but they couldn't then reuse that data, that collection data they may have paid for, it be it that drone flight or that survey, and things were very isolar and very disjointed. And so what we wanted to ensure that through the path it was configured and designed at its core to be able to think about the data lake concepts, to be able to pull out of those, that the client would own the data, control that data and take it forwards. I use on this slide a pre-configured, and during some of the work that we did around this, someone else described it as a headless digital twin. Whilst slightly less flattering, it's the pre-configured element of it is such that we wanted to be able to have done some of those routines. We know how it all plugs together so that you can very quickly get to the solution. I should say at this point that Deloitte is never going to build photogrammetry software. Or I say never, I would never say never, but it's very unlikely to build those things. So this is really about working with a system of partners. Once we have done those pre-configurations, I touched on it earlier, a lot of the work of going scan to BIM, taking different types of environments and bringing them together is incredibly manual, incredibly time consuming. And so there are two parts of automation. One is automation, the workflow. The second is automating the machine learning and object recognition. Some of the best skills and ways of doing that is at the point of collection, making sure that it's tagged and done in the correct way, but also then, as we discussed previously and in these examples, automatic recognition of parts, change detection in terms of crack movement, and also the sort of where you have, and a big one for climate is where you have environmental change, be it over long periods of time, which you would normally sort of expect with a sort of wide scale orthosomatic vector shapes. Those skills are there, ground truthing that goes with it. And then the end-to-end integration, and that we've touched on in terms of asset, one single point of the truth and the asset workflow. But secondly, it is around a lot of what we did around creating the platform was to say there are business solutions out there and we can serve. For example, we have a security product that we work with clients around that gives them very location-based security environments. But the security people wanted to be able to do 3D walkthrough of buildings and their wider environment. And we, rather than having to create a whole new UI or things, we were able just to serve up it in a frame within that end use case. And the other thing that I would touch on here, which leads nicely onto the last point around this, is that we also configured it in such a way that enables us to understand how you manage things like user rights, license fees, that those are passed through in a way that means that the ecosystem of providers can easily scale in and out of a project depending on the value they bring and what they want to achieve as their business objectives. And this ecosystem of providers is absolutely at the core of what we do for AssetMesh. AssetMesh was designed to be able to, and there are lots of techniques, be it APIs, VMs, containers, Dockers, Kubernetes, all of those things that you would sort of expect from a flexible architecture. But what we wanted to ensure that we could put the client at the control of what they wanted. So if they were already an Esri house, you could use their ArcGIS instance. If they had a Bentley suite, we can use Bentley Capture or Hexagon, Point Fuse, and servicing up into a sort of a Unity type environment that allows all of that interaction and GUID at the top. So as I say, for us, it is about, there are incredible things that people have, particularly SMEs, but others have worked on in solving some really, really important challenges, from algorithms that look at flood detection to how people move in an environment, weather predictions, all of these things. There are, as I say, the Met Office being based in the Southwest is another one, the UK Hydrographic Office. There are organisations that have created great value from their insight and their modelling on that. We do not want to try and create the wheel with the environment. We believe that one of the reasons to be ridiculously optimistic about the future is the collaboration and the environment that we can create by using things like Deloitte's network and integration skills with the intelligence and solutions that third parties have developed to integrate in to create a larger business or societal impact. So the sum becomes greater than the parts. And I just really want to go back to saying that at the core of why we are excited and where we see this place going, and how you create the value from a digital twin, is by working with partners, providers, alliances, collaborations, and that is why we created a platform to enable us to be able to do that in a light touch, quick manner, which, for those who know big firms and light touch are two words that tend not to go together too well. So just to, now we sort of understand now I've given a little brief and overview into the insight about why we looked at creating a platform around a digital twin. Most of these, I would imagine, are commonplace and understood for everything, but these are some of the areas where we have either delivered already or are looking to deliver in this space. Training, from as simple as during COVID, creating a training environment for a transport operator that allowed their users to be trained remotely and get that signed off by the regulator to say that the model they were creating on was a true representation and that it met the training KPIs that were required. Very simple model, as I say, in a single asset in a disconnected environment, through to later on there's a talk around motion simulation, which is a scheduling tool that we also did for a different transport element. Scan to BIM, being able to look at an asset and say this is how it exists today, take it back to its fundamental 2D CAD and BIM so that you can move elements around it, reduce the planning time dramatically for each of those sites. Remote inspection, as I say, looking through something through augmented reality, again, driven home massively by the restrictions on movement through COVID to ensure operations. But also, I mean, it ties, for me, it ties in hugely with safety. When you talk about the value of a digital twin, are we talking just about financial value or societal benefit, but also the safety? And if we can remove people from dangerous environments and costly environments, it is why one of the bigger use cases for drone inspections to date has always been offshore oil and gas, and that will include with things like renewables going forwards. Having a deeper understanding and being able to access maintenance points that you wouldn't currently have been able to do. Real-time monitoring with IoT devices that integrate into your asset workflow that can immediately give you alerts, responses, but in a consolidated manner that is integrated across all elements, so that you know if something triggers it, you know where it is, you can see the wider impact of what it does, but also it then immediately triggers, say, the ordering of a new part or create the work order to have it fixed, and then you can use visual inspection to tick off that either through a photo, and that exists within the rich architecture of the digital twin that you've created. Change detection I've spoken around already. Asset optimization likewise, and then the security example I gave earlier of how they use it to monitor a site and create a secure environment. All of those have very different requirements from the level of accuracy that is required, so that the collection of the data and the elements around it are completely different. So one thing that I realized when I was writing this was that it was very heavily based around physical assets, and it is targeted generally at organizations that have large asset infrastructures or any infrastructure. But one of the advantages of having the wide area, sort of more GIS geo environment built into AssetMesh is it does allow us to do and work with Google Earth Engine and others to be able to do wide scale understanding of what change detection looks like in the environmental, not just in the assets space. An asset example is, and the use case that has been talked about many times, is the movement of soil around construction sites, but it's also can be things like the movement of walls on farming, and how that can revolutionize how we can automate the workflows around delivering a different type of grant to the UK agricultural economy as we move away from the single farm payment into wanting to create a more biodiverse, regenerative agricultural environment. You can also tell that, well, hopefully that I have a small holding, so I'm very keen about how we have biodiversity and across our economy, and being able to use the environment to make that change, and but to be able to ensure that we do it understanding the value it can drive. So last but not least, does it pay? What we discovered in the marketplace was there was an incredible amount of excitement around things like drones, geospatial technology, location-based data. There are obviously and digital twins is not a physical digital twin, a photogrammetry model, a point cloud is not a new concept, and there is definite value, particularly I think in the safety aspects of of removing people from harmful areas, and it is incredibly exciting. But those in themselves tended to be much more in either in the very high engineering space where they were used for survey, and those will always exist and continue. But they are relatively low margin work that is driven by a much larger scale project. This is about it becoming ubiquitous with how people go about their business, looking at physical and location and codifying the physical world. The ways to make it pay, and the ways that we've seen that is through having an integrated solution that will scale us through the next phases of that rollout going forwards. To give some examples from the telco environment, the IDC predicts that you'll get about a 25% productivity gain across this, and when these markets scale hugely, as the telco market will, or as we build more houses, or there is much more of a demand on business doing ESG reporting, how are we actually going to use that understanding that we've created of the physical world and integrate it into the businesses around and your clients to see real benefit. So to close on three real sort of key thoughts that come out of a digital twin and what we've been talking around. The first one is very much based on a collaborative, integrated environment. There have been incredible elements done by organizations that have understood a problem and created a bespoke solution for that. The crossover of that value and how we can now take it to the next level, I believe, is part of collaborating together, working on the skill sets that each organization have, understanding how that can be done rapidly so it doesn't become a behemoth of a consortium or anything like that. We have very fast moving sort of low code, no code environments that will allow us to get to a solution for our clients quicker that is integrated across their workflows. And as I say, the next one is the integration. It is great to solve a business problem, but if the business doesn't have the time or doesn't have the people to be able to interact with it, then it will only reach part of its potential. That integration is really critical to be able to take some of the physical digital twin work to the next level. And the last one is sort of goes back to 101, is that there are lots of things physical and digital twins can do, and some of it is really, really cool, and the sort of tech excitement in me just wants to go and do it because it's cool. But driving home and understanding the business value, the cost base against the value it will bring, is one that must be really understood. And if we can reach the point where you have a collaborative, integrated environment where a business can say, I need to take an investment position on this, because actually by having an accurate understanding of my infrastructure now, how frequently it needs to be updated and what the ongoing running life cycle of that is, actually it might mean that it does make sense in the first pass to create a digital twin that is more accurate than the immediate business case. But if they get the buy-in from the business throughout, saying this is actually a 5, 10 year, 20 year program, and this is how it integrates, and looking at it across its life cycle, hopefully means that we can move some of these programs that have been in the R&D piloting stage into the commercial scalable stage. So as I say, time to be ridiculously optimistic, because I think a lot of technology, society are moving towards wanting to understand the physical world better, and being able to use that to drive value and societal good, I think, is an incredibly exciting place to be. So I'm going to come off that presentation, and hopefully there is yeah. Right, so at the moment it doesn't look like there's any questions. So if there are no questions for me, I shall say goodbye. Thank you very much for attending.